So one thing I'll talk about is wood density. So we've talked about how thick leaves are, but the density of wood also has an importance for arid land plants. Sapwood is this functional xylem around the outside of the stem. And we talk about sapwood density because high density wood has narrower xylem vessels. Remembering that narrower xylem vessels have lower hydraulic efficiency. So they don't transport water as efficiently. They don't transport it as much as if they had less dense wood. That's fine because they might not have a lot of water to transport anyway. Desert plants, arid land plants tend to have thicker leaves, partly because they have so much sunshine that they need these multiple, their highlight leaves, they need these multiple palisade cells. They also tend to have some protecting cells between the palisade and the epidermis to really try to slow down that cuticular transpiration I was talking about before. But so basically, you expect arid land plants to have thicker leaves or low specific leaf area. And indeed, we see a very good relationship between precipitation falling off and specific leaf area also falling down, or leaf thickness getting larger. So now we're moving on to the Australian plants because they're really neat. I'm going to just talk about a few. We have the mulga, which I've already been talking about a bit. Tend to have phyllodes instead of true leaves. These are modified petioles. They're not actually leaves, although they will grow leaves at the tips of their petioles when they first germinate, when they first come out, and then those fall away as they start to experience stress down the track. These plants have been used indigenously for food because, remember, these have nitrogen-rich seeds, and they've also been used for wooden implements like spears and boomerangs because their wood, when it's wet, is really flexible. You can do whatever you want with the wood when it's wet. You can straighten it, you can curve it, you can bend it, whatever. Then it dries hard as because it has a really high wood density. And so it's really useful for things that you need to shape and then keep that shape indefinitely. Has some really interesting photosynthesis because as I didn't mention today but have mentioned before, Australia can be a land of quite extremes of droughts and flooding rains. And so a lot of these plants have to survive both the really, really wet times and the really, really dry times. And mulga can do that by having relatively high photosynthetic rates when it's wet, and then practically no photosynthesis when it's dry. So it basically turns on and off, switches on and off. Another plant that covers so mulga covered 25% of the continent, and hummock grasses cover an entirely different 25% of the continent. These grasses are really neat because when they first grow a new leaf, it's a regular grassy leaf, flat, just like a grass. But it doesn't take very long, it doesn't take the soil to dry very much before it starts to roll those leaves up into long tubes. These long tubes and all the stomata are in substomatal cavities within those long tubes. And so what happens is when they close that tube, basically all of the gas exchange can only occur through the tip of the tube. So water evaporates from the mesophyll cells inside the leaf, then it comes out through the substomatal chamber, out into the main chamber, and then it has to get all the way to the tip of the tube. This gives them a very, very high water use efficiency and allows them to maintain photosynthesis all the way through the dry season. In some parts of the range of hummock grasses, the dry season can have no rain whatsoever. And it'll still keep going because of this very high water use efficiency.